Here we look at the gray code using the definition of exclusive OR. So what I've done is I've written the decimal value as base 10 over here, so just from 0 to 7 to give us an idea. And in the column to the right is the binary base 2 representation of the number 0, the number 1, the number 2. We're used to the binary base 2 representation. And on the far right, I've written the gray code. And this gray code is using something known as exclusive OR. And if you notice, the most significant bit going from the binary and to the gray code, they are going to be the same. So if you look at this first significant bit here and here, they are exactly the same. So if I'm going from base 2 over to the gray code, how can we do that? So if I look at the binary, let me pick on one of these that I want to move over, so I'm going to erase this. Let's say that I want to take the binary number 0, 1, 0. So I'm looking at 0, 1, 0, and that would just be this one. Okay, so what is its corresponding gray code? Okay, its corresponding gray code I know is going to be 0, 1, 1. And the way that we do this is we know the first significant bit is going to be the same. So we drop it down, okay, we keep that. And then going to the next part, I want to look at the 0 and the 1. So the 0 and the 1, you're going to do an exclusive OR. So what is 0 XOR 1? 0 exclusive 1. And so I've written the table over here if you're not sure. So 0, 1, and that's going to give me back a 1. So this output is a 1 here. Then I look at the next two. So I look at 1 with 0 as an exclusive OR. So 1 exclusive OR 0, again, is going to be a 1. So you write down a 1. So that is the corresponding gray code for this one. And we could do another. Let's just do another binary. So if I look at another binary number, let's pick on 1, 1, 1. So if I do 1, 1, 1, let me just go ahead and write that's binary. So I'll put a 2 down here. So if I want to get the gray code, so I'll write down maybe I'll just write down gray for gray code. The most significant bit is going to be the same, so I'm going to drop down this 1, and then I'm going to do an exclusive OR. So the 1 and the 1, you're going to do an exclusive OR, or just write XOR there. So what is 1 XOR 1? If you look at the table here, the truth table, you know that's going to be a 0. So you drop down a 0. Then you do the next. Then you do 1 XOR 1, and you get the same, you get back down a 0. So the corresponding gray code is a 1, 0, 0. So this method allows us again to form that gray code I was talking about earlier when we were looking at n cubes. So we use gray codes when we use Carnot maps. They're going to be known as K maps. It's going to help us with simplifications, and you do want to look at that video on K maps. So what we would have here is we could organize this in this K map chart where we have A, I just put A over here, and then I put the other two, B, C. They're going to be represented by 0s and 1s, so they're just going to be bit strings of length 3, but I wanted to have a gray code so that each of these are changing in only one significant bit at a time. So notice you're going from 0, 0 to 0, 1 to 1, 1 to 1, 0. So that's a Hamming distance of 1 there. And then the same thing that you could have reordered them a little bit if you wanted to, instead of using, let's say, you wanted to start with 1, 1, that's fine. If you want to start with 1, 1, then you could go to 0, 1. Then from there, what would you do? You could even go to 0, 0 from here, and then from 0, 0, you could go to 1, 0. So you're just having a change in one bit at a time. So that would work as well. Okay, and what this is going to mean to us is this is going to mean the 0 is going to mean that it's going to be not B. So that's why I've written B complement. And then the C is right next to it, so that's going to be B complement, C complement. When you write 0, 1 for this one, you're going to read it as B complement C. And then when a 1, 1 is going to represent take B and C, so it's going to be BC. And then 1, 0 is going to mean take B, but then take C complement. So that's how we're going to be reading these when we start looking at the K-maps. Now also notice that these edges would wrap around to form what's known as a torus. So just think about wrapping these. It's hard to think about this. You might want to look online to get some ideas, but I would actually bend this edge over here and connect it with this edge over here. So think about taping those together. But then you'd also tape this edge together with this edge over here. And then it would form what's known as a torus. So you'd have this kind of shape here where they're all together. And what does that mean to us? Well, that means that if you look at the gray code or any of these cells, they're going to be adjacent to each other as well, which we'll talk more about when we do the K-maps.